So today we want to talk about using the new Lambda function in MS Excel. And it's through the beta channel and Office Insider. Beta channel was formerly called the Insider channel, and it is the channel that's best suited for those people who want the latest builds to identify issues and provide feedback about the new features and development by MS Excel developers. So you can use it at your own risk, but there's some very unique and interesting functions that are starting to being developed within MS Excel. To be able to use these functions, you have to make sure that you are a beta channel user or you're signed up for the beta channel. And to be able to ensure that you are on this channel, just go under account in MS Excel and click on Office Insiders. This is for those who are on a subscription basis with Office products, and click on the channel and make sure that you're signed up for the beta channel. There are two types of channels, the current channel preview and the beta channel. And under the beta channel, you can have access to all of these very unique functions. And you might actually do this change and switch to beta channel, but not be able to see these functions immediately. Just make sure that you have updated MS Excel and restarted your Excel and restart your computer to be able to have access to these functions. And as you type Lambda, you can see the function. So if we go on Help and just type in Lambda, and you'll be able to see the instruction for the Lambda function. And under this section, you would see Lambda function description. You can create functions for commonly used formula, eliminate the need to copy paste it. You don't need to write macros. You can see the inputs, the parameters, calculations. You can see some remarks of what to do's and not to do's and don'ts. So 253 parameters max when you're getting a hashtag value error, when you're getting a hashtag number or calc error. Just don't use dots in the name of the parameters. Just be consistent with how you name your parameters in Excel, and also the steps. To test the formula, create the Lambda in a cell and then add Lambda to the name manager. So we're going to walk through these 3 steps for 2 different examples to see how to do it. Okay, so one of them is a Jensen's alpha when it comes to financial markets, when you want to look at the historical performance of a stock relative to the market. One option is to look at Jensen's alpha to determine if the management have been doing a good job running the company, if we're having positive excess returns, or relative to the market, company is not doing really well. In this case, the public equity and the public markets, that's what we're referring to. So we can see here 2 data columns. One is the monthly market returns and the other one is monthly stock returns. So we calculated the returns on a monthly basis for the stock and the market. You ran the regression of the stock return with respect to the market return data, and we calculated the intercept and the beta of the stock. In this case, our square is quite small, but just for the purposes, that's what we're going to use. So what's the formula for the Jensen's alpha? The intercept, and we subtract from it the T-bill rate on a monthly basis times 1 minus the beta. And in this case, beta is calculated on a monthly basis. And then we have to annualize that value, which is 14%. So it's positive. We can't say we can't say specifically if the stock has a high or low Jensen's alpha, because we have to look at other peers in the market and then compare this Jensen's alpha to the average of the peers or the median of the peers in the market. For the sake that this is just positive, it's not going to specifically say that this is a good stock or the management have been doing a good job at running this company from an operational standpoint. But you see that this formula is consistent. It's the same formula all the time. It's basically the intercept less 1 minus the beta times the monthly T-bill rate, which is divided by 12. So we can simply create this by a Lambda function. First, we write the overall formula for the annualized Jensen's alpha, which is 1 plus the Jensen's alpha on a monthly basis to the power of 12 minus 1 to get the annualized basis, and the Jensen's alpha on a monthly basis is basically the intercept minus 1 minus the beta times the t-bill rate, in this case, divided by 12 because it's on a monthly basis. And then in order to write the Lambda function, the first parameters are parameters for calculation, and we can name them the intercept, the beta, and the t-bill rate. These are the functions, the parameters that we're going to pass into the function that we're going to create. We're going to call that function later on the Jensen's alpha function, so Jensen alpha, and we're going to have 3 parameters for it, which is the intercept, beta, as well as the average t-bill rate, which have been previously calculated, but here's a hard code because we're passing it into the formula. So for Lambda function, we simply write lambda, intercept, beta, and the t-bill rate are our inputs. Then we calculate the function. We basically put the function formula for it, and then we pass in the argument. Just to tell you how we write this, we say lambda. In this case, we say intercept, and comma, and then we have regression beta, and then we have a t-bill rate. Okay, so these are my formulas. And then I'm going to pass in the formula, which is 1 plus intercept minus 1 minus beta times t-bill rate divided by 12. Okay, so 1 plus that to the power of 12 minus 1. Basically, that closes the Lambda function. And then I have to pass the parameters, this parameter, and then this parameter as my value to name this function. So now that we create this function, we have to name it. Simply, you can copy paste this portion of the formula with the equal sign, put Alt M N to get a name manager, and then you would have to add a new variable, which we have new name, as in this case we have created a new name, which is Jensen's alpha. You can edit it, and in this case you have to put in, or we would have to put in, the formula that we just copy pasted, and then we can name it. We call it Jensen's alpha, and then we can put a description that this function calculates the stocks Jensen's alpha based on the monthly t-bill rate, intercept, and the regression beta of monthly stock returns and monthly market returns. And then we actually write, this is our function, Jensen alpha equals intercept minus monthly t-bill rate times 1 minus the beta. So now that this is created, when we go into the Jensen's alpha, we can just write Jensen's alpha, just showing you Jensen alpha, click tab to complete it. Remember the order of the parameters: first intercept, then the beta, and then the t-bill rate, which is average annual rate. And then you will be able to getting 14.6%. So then we won't have to be doing all of this calculation to arrive at its 14.6%. You can have more stock return data as long as we have the intercept, the beta, and the t-bill rate. We can just type Jensen alpha, pass these 3 variables, and then get our annualized Jensen's alpha. The second example we're going to look at is the average price at a wholesale store. This is not financial market related, but it allows us to pass, in this case, more like array functions to the, in this case, average price array functions as parameters to the Excel, as into the Excel formula average price. An average price is a function we have created. So what's the story here? The story here is that we have a wholesale store, and there are a few inventors that come into the store, and they have their inventions and prototypes, and they want to sell it to customers. And this wholesale store acts as a distributor for them. Basically, for the store to accept their product, they're going to write an exam. So these are the test scores. In this case, we have used the RAND function to create their test scores between 0 and 100. And these are the number of prototypes that they bring in. For instance, person A scored 60 on the exam out of 100 and brought 93 prototypes. The store says that the passing score is 70. So if this individual had a score of less than 70, the store is not going to accept that prototype and they're not going to sell it. So if you see, we have conditionally format this column that these three people, in this case, C, D, and E, got scores higher than 70. And their prototypes, they brought these number of prototypes, and the prototype price is basically the price that the inventor is assigning for their products. And basically we made it a skill-based price. We're saying that if the person scores 60, the base price is 100, and we're going to say 60 divided by 70, which is the minimum passing score, times 100. He's going to price it at $86. But this person, which scored 91, he has more skill, so he's going to price his products higher at 130. The store would then add, see how many people have passed the exam, over 70, basically, these number of stores. So these number of people, 3 people have passed. The acceptable prototypes is basically the sum of these prototypes, in this case, which is 189. And for this, we use formulas. We say if this column, as long as the passing score is larger than 70. That's a formula 1. We use the second formula is we're going to select acceptable prototypes. We're looking at the number of prototypes. How many prototypes do they have? They have these many prototypes. We accept them as long as a passing score is larger than 70, which is in this case a passing score. So sum if number of prototypes as long as the inventor score is larger than 70. And then the proceeds from these prototypes is base product. We're basically saying the sum product of the price by the number of prototypes, column E in this case, as long as, so we put a bubble, as long as the passing score is larger than 70. So if you have just highlight this to show you this is basically a true or false, click F9 and you can see false, false, true, true, true for these 3 people who have scored higher than 70. Okay, so that's the proceeds of the prototypes. And in the end, the average price of the prototype is these numbers divided by 189 prototypes, number of prototypes, proceeds from acceptable prototypes by 189 prototypes. So the store is going to sell each prototype for $125. Okay, so this calculation is quite tedious. If it was just one function for the store that says average price, how do we calculate it? And we just have to pass in 3 arguments or 4 arguments. So the passing score, the investor test score, the number of prototypes they brought in, as well as the prototype prices that the inventors assigned to their products. And then we get 125, which is what the Lambda function did for us in this case. So the first way, the first step is to just write the formula, sum product. So it's basically this formula divided by this formula, which is sum products divided by the sum if function for the number of prototypes. So that's what we have done. The second step is to use a Lambda function. Again, we write an equal Lambda, and then we pass our parameters, which is the passing score in this case, the test score of the inventors, this is an array, the number of prototypes, this is an array, and the price of the prototypes the inventors are assigning to their products. And then the next argument is basically the formula we're going to use, which is going to be repeated, and we're going to call it average price. We wrap an if error function because this is a division. In case none of the inventors pass the exam, we're not going to get a pass divided by 0, so we're going to get test score that there are no acceptable prototypes in this case. So then we write our long formula, and the best way to do this is copy paste this function and bring it in here under the if error function in this case, and then replace the parameters. So I would say if I'm writing a Lambda function, I would say A, B, C, and D are my inputs. Then I would put the function here, and we have wrapped an if error function in this case. After that, no acceptable prototypes And then we replace them one by one. F, prototype price, which is in this case D. And then E in this case is C. These are our parameters that we're passing it. D in this case is B. And this is A, our passing score. And again, we're going to have sum if these numbers, the inventor score was B parameter, so we're going to put B here. And then we're going to put A here, our parameter. E was the C function or C parameter we passed on. And then there's no parameters. And then once we close this, we have to pass in our parameters, which is 70, comma, A parameters, B parameters, C parameter, and then D parameter. Just ensure all of the parameters, parentheses are closed properly. And I click it and see 129 in this case, which is 130 for the average price we calculated. And then once we did this, we just copy paste the whole formula minus the parameters that we're going to pass in at the end. And you go Alt-MN for name manager. We create a new name for average price. Then we just copy paste the formula in this refers to space. And we can write a simple description. The formula calculates the average price per prototype at the wholesale store, and acceptable prototypes are those that are provided by inventors that scored higher than the passing score. And then we can write the formula. The average price is basically the proceeds from the acceptable prototypes divided by the number of acceptable prototypes. So we can use this function, and then we can write average price, pass on these parameters, which is the passing score, the inventor score, number of prototypes they're bringing in, and the prototype price. So in these two very simple cases, we saw how the Lambda function allowed us to minimize steps that we have to perform in an Excel function, in an Excel environment, and be able to use that same function over and over again without having to redo all these calculations all the time. And on this side, we have basically done a very simple Monte Carlo simulation for our trials. For 100 trials, we looked at the acceptable number of inventors. And this is basically a data table. And we looked at the average price. In this case, there are cases when you might not get, we might not be able to actually get any acceptable inventors. So we just say if this column O is a number, we're going to have that number. Otherwise, we can have 0. And then once we look at the median and average of these prices, we can see that the average means that most of the time they're going to be selling the products at roughly around $120 per prototype.